laptops, smartphones, and data centers are expected to consume up to 20% of all global power generation by 2030. In fact, all of our current technology dissipates at least 10,000 times more heat into the environment than what's theoretically possible. One cause of this energy waste comes from electrons encountering resistance as they're conducting electricity, releasing waste heat in the environment. This is why you feel your phone getting hot when you're doom scrolling at 2 a.m. One way to address this is to build an alternative computing device that can be cooled down to extremely low temperatures, like negative 450 degrees Fahrenheit or negative 268 degrees Celsius. At these mind-numbing temperatures, electrons will no longer face resistance as they're conducting electricity, generating only a fraction of the wasted energy. But I don't want to work at negative 450 degrees. Instead, my research develops mathematical methods and simulation tools for building these energy-efficient alternative computing devices. I showed that these devices could produce around 10,000 times less heat than our current technology when performing the same computations. To give you an idea of this scale, imagine that we were able to shrink an elephant to the size of a mouse. Eventually, when these devices are built, they will live in a storage apparatus. And even though this technology is still in its infancy, it will live in a storage apparatus. And even though this technology is still in its infancy, it will only account for 20% of the entire apparatus's power consumption. And everything else comes from things like external monitors and wiring. My research could help play a pivotal role in keeping our future power consumption down while minimizing our energy waste, all while conserving costly research resources. That way, we can all continue doing everything from doom scrolling on our phones to performing cutting-edge research. Thank you.